This is section 6.6, function operations. By operations, I mean like add, subtract, multiply, and of course divide. And then we're also going to do something called composition of functions. So I have the basic operations of math. Function notation is used here. And function notation is our advantage because we can say a letter of the alphabet and we know which function we're talking about. So if I say the g function, we know that we mean this middle function here, which is tripling every number. If I say the h function, we know that we mean this function right here, which is squaring every number. If I say f, we are adding 2 to every number. Now the definitions of the functions can change. There'll be different kinds of things that they could be. Maybe it's a quadratic, or this one's a cubic, or this one is a square root function. But there's different functions and they can change. This is how I'm naming these. So for function operations, example 1a, whoops, I broke my pencil lid. We're going to add f of x plus g of x. And that can look another way. You could also be f, whoops, that's why I'm using pencil, f plus g of x. So basically it means I'm just adding the two functions together, and this is two different ways to look at it in the book. So I'm going to write down the f function first, which is x plus 2, write down the g function second, 3x, and then I just add the two functions together. Well, the like term situation is happening here, so I can go ahead and add these two functions together by collecting the like terms. Those are like terms, and they become 1 of them plus 3 more makes 4x, and then the 2 follows along. So 4x plus 2. B, you could subtract two functions, h of x minus g of x. Also could be noted as f, not f, h minus g of x. So you write down the h function, which is x squared. You write down the g function and subtract it, and that would actually be the answer because there's no like terms here. C, we're going to divide, well, no, we'll multiply first. We'll multiply two functions together. Let's do g of x times f of x. So write down the g function first, 3x, and then the next function is the x plus 2 for the f. So I wrote down the g and the f. And then we can multiply this together by the distributive property, or if you left it like that, it would be the factored form, so 3x squared plus 6x. So we're just multiplying two functions together. And then D will divide two functions, f of x divided by h of x. And you literally just make a fraction. So you write down the h function on the bottom, no, h function on the bottom, f function on the top, so it's x plus 2 over x squared. Sometimes it'll say, what are the restrictions when you divide here? Basically, you have to watch out for dividing by 0. You're not allowed to divide by 0. So if x was 0 here, you wouldn't be able to do this problem. So x cannot be 0. That would cause division of 0. So there's add, subtract, multiply, and divide. To keep this onto one, or keep the same functions the same, we're just gonna keep going, doing more operations. The next kind of operation is called composition of two functions. So I'm gonna write down here composition of functions, and I'll keep my functions the same. So f of x is still x plus 2, just to keep it simple. G of x is equal to 3x, and h of x is equal to x squared. So I'm going to keep the definitions the same. I'm just going to keep going down with the theme here. These are function operations, which are add, subtract, multiply, divide, and composition of functions. So this will be example 1, a, b, c, d, e. So this is where we're going to put two functions together, kind of like you put a bunch of sentences together to make an English composition. If you put a bunch of notes together, you make a music composition. So that's what we're going to do here, is we're going to compose the functions. Let's see, pick out something here that's not so bad. I don't need those parentheses there, I just wrote them there. So I'm going to get rid of them so not to confuse people. So just make it 3x. Let's see. Let's do f of g of -2. So you're going to work from the inside out with these. When there's a number here, it works best to work from the inside out. This could also be f with a little tiny circle like a degree symbol, g of -2. I prefer this notation up here because it looks like you're putting the g into the f. Here it looks like they're side by side, but they mean the same thing. So I'm going to do this inside first, g of -2 first. So I take the -2 and I go to the g function. G of -2 means I'm putting -2 in here for x. So it's 3 times -2. Well, that's -6. Now the answer is f of -6. We take the -6 over to the h function. No, that's silly, Mr. Jackie. No. You take the -6, you take it to the f function, which is adds 2. So it becomes -6 plus 2, which is -4. You could even go crazy with this. F, yeah, A, B, C, D, E, F. I got to know my letters of the alphabet, don't I? Let's see. Let's do H of G of F of 4. Whoa. Is this going to be a crazy big number or not? Let's see. Do I get all my parentheses? Parentheses, parentheses, parentheses. I need one more there. So I have 3 right parentheses here and 1, 2, 3 left parentheses there. Here we go. So I'm going to work from here first, then to here, and then do the H last. I'm working from the inside out. So I take the 4, I go to the F. I get 6. So I go 4 to the, and I get 6. I take the 6 to the G. 3 times 6 is 18. So now I'm going to take that answer, 18, and go to the H. So it's 18 squared. So it's 18 times 18, which is, oh geez, I lost my, I should know what 18 times 18 is. Shame on me. 18 times 18 is 324. 324. So it's 324. So I did the 4 to the F to get 6. Then I took that 6 to the G. 3 times 6 is 18. And I took that 18 to the H, and I got 324. You can even do functions inside of functions. That's called a recursive function when you repeat the function over again. So A, B, C, D, E, F, G. You could do F of 3. So that would be getting an answer and putting it right back in to the problem again. So f of 3 is first. You get 5. And then you take that 5 and you put it right back in again, and you get 7. So you get 5, take the 5, put it back in, you get 7. So you're just adding 2. So it's 3, 5, 7, and you could just keep adding 2, 3, 5, 7, 9, if you wanted to keep going and going and going. Okay, we're going to do another thing with composition of functions. So I'm going to go to a, well, I'll just write them here on the bottom, but I'm going to repeat the things again. So we get f of x is equal to x plus 2, g of x is equal to 3x, and h of x is equal to x squared. The last part of composition of functions is actually to put the one function inside of the other function. So here we go. This would be GH. Let's see. Let's do g of f of x. So what this says to do is to put the f function inside the g function. Now up here I suggested starting with the inside function and working to the outside function. For this I'm going to do the exact opposite. I'm going to say, hey, what is this g function about? Well, the g function is about tripling every number. So I write that down. Triple every number, triple everything. So it's 3 times something. Now I'm going to put the whole f function into the tripling function. And what is the f function about? X plus 2. This would be factored. If you chose to distribute it, you would get 3x plus 6. No, not 6x plus 6. 3x plus 6. All right, so 3 times that and 3 times that makes that. H, excuse me, I. Let's put the, let's see, f of h of x. And you could even throw in a number in front, like you could put a 2 here. So that would double the result of this. So the f function is x plus 2. So it's something plus 2. And then that's going to be doubled. So it's times 2. So the f function, so there's the, I guess the very outside would be 2, and then the f function is something plus 2. And now you're going to put the h function inside. What is the h function? The h function is x squared, so x squared goes in here. So it's x squared plus 2. The h went inside the f function, and now I'm doubling this. So I get 2x squared plus 4. So composition of functions is useful. Basically, when you go to the store and you buy things that are taxed, you have to add, which would be an addition function, and then you multiply by a number to figure out sales tax. So there's two functions that are happening there, and they're composed together, an adding function and a multiplying function. So what we did here is we did the function operations, addition, subtraction, multiplication, and division. So we did those things. And then we did the composition of functions, where we put functions together, either with numbers or by putting the whole function inside the function.